So, 4 orbitals of carbon atoms are hybridizing. One is 2s orbital and 3 orbital of p or 2p orbital are hybridizing and form 4 orbital of sp3 hybridization. So, each orbital has equal energy. So, in isolated carbon atom you can see that the energy of 2s orbital is lower than energy of 2p orbital, but after mixing the energy is in between the two. The energy of these orbitals is equivalent. So, they are shown in equivalent energy, that is degenerate energy. The hybrid orbital has degenerate energy. The orbitals of equal energy are called degenerate energy orbital. So, the sp3 orbital, or each orbital in sp3 hybridization has equal energy. The tetrahedral shape of methane is shown below. In carbon, the 4 orbital of carbon, that is after hybridization sp3 orbital, they overlap with 4 1s orbital of hydrogen and form methane. The orbital is also shown, the overlapping is also shown. Another shape of methane, tetrahedral methane. So, in methane there are 4 sigma bonds in this molecule. 4 sigma bond are when carbon and hydrogen overlap. So, there are 4 sigma bonds and no pi bond. In sp2 or trigonal hybridization, when one s and 2 p orbital of same shell of an atom mix to form 3 equivalent orbitals, the new orbital formed are called sp2 hybrid orbitals. These orbitals are directed towards the 3 corners of a equilateral triangle, making an angle of 120 degree with one another. So, when 2 p orbitals and one orbital s orbital intermix, so as there is one s orbital and 2 p orbital, so the hybridization is called sp2 hybridization. New orbitals are called sp2 hybrid orbital. The sp2 hybridization, or this is also called trigonal hybridization because the shape is trigonal planar. The 3 orbitals that intermix, they are at equilateral distance. The angle between them is 120 degree and the shape is trigonal planar. So, examples are ethane and boron trifluoride. Each sp2 hybrid orbital has 33.33% s character and 66.66% p character. So, the diagram, the figure shows below is sp2 has sp2 hybrid orbital. There are 3 sp2 hybrid orbitals. So, when one s and 2 p orbitals are intermixing, the third p orbital is unhybridized. This is not taking part in hybridization. This is unhybrid orbital. So, the intermixed orbital is one s and 2 p, and the shape is trigonal planar. The example shown here is ethene. In ethene, one carbon has 3 hybrid orbital and 1 unhybrid orbital. The 3 hybrid orbital are shown in orange color and unhybrid orbital is shown in sky blue color. The unhybrid orbital overlap each other sideways and the hybrid orbital overlap at internuclear axis with each other, and the another 4 orbital overlap with hydrogen, and the shape is trigonal planar for one carbon and trigonal planar for another carbon. The unhybridized orbitals that overlap sideways, they form pi bond, and the hybrid orbital that overlap at internuclear axis form sigma bond. So, there is one pi bond and 5 sigma bond. So, these are overlapping orbitals, sideways overlapping. There are 5 sigma bond and 1 pi bond. S and P bonds in ethylene, that is in ethene. The another picture of a ethene molecule. Here 2 pi lobes are shown above carbon, above and below the carbons, and 4 hydrogen are overlapping with 4 hybrid orbital of a carbon, of 2 carbon. So, the electron density is also shown here. sp or linear hybridization, when one s and one p orbital of same shell of an atom mix to form 2 equivalent orbitals, this is called sp hybridization or linear hybridization. As there are only 2 orbitals, one s and another is p, new orbital formed are called sp or hybrid orbitals. These orbitals are oppositely directed away from each other at angle of 180 degree. Shape of linear hybridization is linear. sp hybridization shape has a linear shape. Bond angle, as they are directed towards the opposite to each other, so the bond angle is 180 degree. Examples are acetylene or ethane and beryllium dichloride. Each sp hybrid orbital has 50% s character and 50% p character. So, here one s and one p orbital is intermixing. The intermixed hybrid orbital is called sp hybridization. The another 2 orbital are shown that are unhybrid. Here is one s and one sp orbital of one and sp orbital of another carbon. So, the example of acetylene or ethane. So, one carbon with orange orbitals are hybrid orbital, they are intermixing with each other. So, they are overlapping with each other, so and forming sigma bond. The 4 orbital unhybrid orbital of 2 carbons, they overlap each other sideways and form 2 pi bond. So, this is unhybridized orbital which are shown in green color, and the hybrid orbital sp orbital are shown in red color. So, these are overlapping orbitals, side by side orbitals, side by side overlapping. So, this is another figure of sp hybridization acetylene. So, there are 4 lobes of pi bond. So, one above and below the acetylene molecule, and another is in front and back of the acetylene molecule. The 4 lobes of pi orbital shows 2 pi bond. So, in third figure, this is shown the electron density around the carbon molecule and hydrogen molecule. Now, the multiple choice questions. Now, in today's lecture, we have learnt about the orbital concept of covalent bond and hybridization. So, in hybridization we have learnt about the sp, sp2 and sp3 hybridization. So, the number of valence electrons in carbon atom is, how many number of valence electrons in carbon atom are? So, atomic number of carbon is 6, 2 are in ground state and 4 electrons are in valence shell. So, the answer of first question is 4, that is D, answer option is right. So, there are 4 electrons in valence shell. A covalent bond is formed by donation of electron, transfer of electron, mutual sharing of electron and acception of electrons. Covalent bond is formed by mutual sharing of electrons. Triple bond consists of 3 sigma bonds, 3 pi bonds, 2 sigma bonds and 1 pi bond, 1 sigma bond and 2 pi bonds. In a bond there must be a sigma bond, and in sigma bond and there are 2 pi bond. There should be in triple bond there are 1 sigma and 2 pi. So, the best option is D, 1 sigma and 2 pi bond. A pi bond is formed by the overlapping of SS orbital, sp orbitals, pp head on, pp sideways. So, pi bond is formed by sideways overlapping of pp orbitals, as only pp orbital overlap sideways. So, the option is D. Which of the following is linear in shape? So, linear shape is in sp hybridization. So, first A is sp3 hybridization, that is tetrahedral shape. Carbon dioxide is a linear shape. Water bent shape, sp3 hybridization, and ammonia is also sp3 hybridization, and that is a pyramidal shape. So, the best option is B, carbon dioxide. So, sp2 hybridization give rise to a planar structure, tetrahedral structure, octahedral structure and linear structure. So, the shape of sp2 hybridization is a trigonal planar. So, planar structure A is best option. Tetrahedral structure is for sp3, okay. Linear structure is for sp hybridization. Hybridization is the intermixing of orbitals of dash. Hybridization is intermixing of orbitals of not same energy, very different energy, slightly different energy, none of these. So, hybridization is intermixing of orbital of slightly different energy. So, the best option is C, orbitals of slightly different energies. True, false. Molecules of boron trifluoride is tetrahedral. Is it true? Molecule of boron trifluoride is tetrahedral. This is not tetrahedral, this is trigonal planar. So, the first one is false. Sigma bond is stronger than pi bond. This is true. Sigma bond is always stronger than pi bond. A bond is formed between two atoms only if the process results in the increase of potential energy of the system. A bond is formed between two atoms only if the process results in the increase of potential energy of the system. So, when the bond formed, the potential energy of system is decreased. So, this is false. So, potential energy system should be decreased when the bond formed. Only the bond formed only when the potential energy of system decreases. The bond angle between the two covalent bond in carbon dioxide is maximum. Bond angle between the two covalent bonds in carbon dioxide is maximum. This is right. That is true. Carbon dioxide is a linear shape, has a linear shape. And the bond angle is 180 degree. So, this is the true. So, first one is false, that is trigonal, that should be a boron trifluoride is trigonal. Sigma bond is stronger than pi bond, that is true. So, bond is found when the potential energy system is decreased, this is false. So, potential energy system should be decreased, this is the increased. So, third is false. The bond angle between the two covalent bonds in carbon dioxide maximum, that is true.